Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will review set theory and notation. So firstly, we have a three-way Venn diagram here, and we're going to write in set notation the region that is shaded. So these questions can be tricky. Let's just go region by region. So we sort of have one continuous region here shaded. Let's start by writing that in set notation. So what do we notice about here? Well, we notice that this is in B. All of this part that's shaded is in B. So I'm going to have a B somewhere. So I'll start by writing that. Now, we also know that all of this that's shaded is not in C. It is in B, and it's also not in C. Now, I want to use an AND symbol here because B or not C would include the whole of B and also the whole of not C. So I definitely don't want that. So this is B and not C. So what about A? We have one region that's in A and one region that's not in A. So we could write this. We could write that it's A or not A. But of course, A or not A basically is everything. This really doesn't add anything at all to our set notation. It's not wrong if we write it like that. You don't always have to write it in the most efficient way. But I'm going to get rid of this because I don't really need it. It doesn't really matter what happens to A here. This region is just everything in B that is not in C. So now I want to also include this region here. So these regions, of course, are non-overlapping. This is like a totally distinct region. So to include this one, am I going to use and or? Well, I don't really want to use an and here because that would mean that I have to include what's in here and in here, even though there's no overlapping region. So I'm going to use an or. So I'm going to basically say this region or this region, which covers everything. So what is this region here? Well, let's look at where we are. This region is in A, it's in C, but it's not in B. So what we could do is write that as it's in A and C, but it's not in B. It satisfies all of those things simultaneously. That's why I use ands. So I don't actually need brackets around this because and takes precedence, but if you put brackets around it, it might make it easier for you to understand. It doesn't actually change it. So that is a region I have shaded in here. Let's look at going the opposite way now, where I'm given the set notation and I have to shade it. So I'm going to shade the region corresponding to not A or B complement. When you have a complement outside the brackets like this, it's useful to locate the region listed inside the brackets and just shade everything else. So let's go and locate the region not A or B. So or means it has to satisfy either of these. So I've got to include everything that's not in A and everything that's in B. So this outside region is included in not A or B because it's not A. This one is included because it's both. This region here is not A, it's also B. I include both for OR questions, and then I need to include this region here. The three ticked regions correspond to not A or B. So I wanted to shade not A or B complement. So I want to shade in everything but these three regions, which of course just leaves this part here. So here we are and we're done. Just note that this is exactly the same region as not A and B. You can write regions in a Venn diagram in different ways. All right, let's look at shading in this region here. So not A and B or C and B and not C. What I'm going to do is locate this region, and then I need to shade in just what is in both of these. So looking at the first region, this and takes precedence. This operator occurs first. So it's not A and B first, and then we include C. So let's look at not A and B. So that's everything that's in B but not in A. So B is these four regions here. Which of those are not in A? Well, it would be this one and this one. So now we need to include everything that's in C. So we're going to include this region, this region, this region, because they are all in C. So we want to include everything that's not A and B, everything that's C, or everything that's both. So now we're asked to include what is B and not C. So which of these regions is in B and also not C? Well, it turns out that it's only this region here. This is the only one of the regions that's in B but not in C. Because of this AND operator, I can only include what is this and this. So I am only going to include this region here. So we have to do it systematically in order to be able to shade the correct region. That is it. We are done. Now let's look at using this to solve probability problems. So here I have two Venn diagrams, and we'll use what we've learned on the previous slides to solve probability questions. The first asks us for the probability of A and not B given A. So what does that mean? Well, given A means that we're restricting our attention to the A circle. So in the A circle, there are 14 options, 14 choices. So I just have to figure out how many of those 14 options satisfy A and not B. So which region is A and not B? Well, and means it has to satisfy both. It has to be in A. It also has to be outside the B circle. That only leaves us with those 5 there, so the probability is 5 over 14. So let's look at this question. This says the probability of B given A or B. So I know that because we are in the A or B circle, there are 5 plus 9 plus 4, there are 18 such choices. So all I have to do is figure out how many of these 18 choices are in the B circle. Well, 9 plus 4 is 13. So the probability there is 13 over 18. So let's look at this Venn diagram and attempt these questions. So this first probability question says probability that we're not in A or we're in B and not C. So remember that the AND operator takes precedence. So we can put brackets around here if we like, just to help us. We always do this one first. So let's look at the region that's B and not C. So I want everything in the B circle that is not in the C circle. There are 4 regions of the B circle. These 2 are not in the B circle. So I'm going to give them a tick. They satisfy B and not C. Now it says not A or that. So I have to include this part here, which I've done, but I also have to include everything that's not A. So I'm going to go ahead and tick every part of this that is also not A. So you can see that I have all of these regions that are ticked. If you add up the numbers, 7 plus 5 plus 8 plus 3 plus 2, you get 25. And if you add up all the numbers in total, you get 36. So the probability is 25 over 36. All right, let's do this one. It says probability of B given A or not C. So because of the given, we know we're going to restrict our attention to A or not C. So just getting rid of the ticks from the previous question, now I'm going to go and tick the regions that satisfy A or not C. So that means anything in A, anything in not C, or both. So because it's anything in A, I need to go ahead and tick all that's in A. Now I'm going to go ahead and tick everything that is not in C. These ticks correspond to the regions A or not C. Everything in A, everything that's not in C. So I'm restricting my attention to those regions. Now, if you add up all of those numbers, it'll just be 36 minus 13, which is 23. So the probability of B given that. So I'm saying I know I'm in one of the ticked regions. What's the probability that I am in B? Well, let's go and add up those ticked regions that are in B. 3 plus 6 plus 2. There are 11 such choices. So then I'm done. Alright, thank you so much for tuning into this video. Hope it's been useful. This has been the luckiest maths teacher in the world. Have a great day.